Hello everyone. This course is about IoT industry applications and solutions, the second course of HCI IoT series. In the last course, we learned about the basic knowledge and the hierarchical architecture of the IoT. In this course, we will learn about typical IoT industry applications. As we mentioned in the last course, many products and applications in our daily life are related to the IoT, such as wristbands, shared bicycles, and vending machines. The IoT has penetrated into every aspect of our life. Many industries are already using IoT technology. In this course, I will explain problems encountered in the domains of smart city, smart campus, smart grid, IoV, and industrial IoT, and the benefits of using IoT technology. In addition, I will introduce the development trends of the IoT based on other popular technologies. Upon completion of this course, you will be able to understand the problems encountered in smart city, smart campus, smart grid, IoV, and industrial IoT, and how to solve these problems. You will learn about the development trends of IoT technology based on the 7 new technologies, named 5I ABCDE. First, let's look at the problems encountered in smart city and the solutions. Smart city is a big topic because a city contains many elements, which can create a plethora of problems. Here, we examine a few common problems. These problems are relatively big and typical. The first problem is traffic management, which is critical to urban development. A highly developed city must have a correspondingly developed transportation system. If we want to make a city better, transportation is one of the first issues we need to address. In cities, traffic accidents and congestion occur often as a result of drivers disobeying traffic rules. This forces other drivers to waste more time on the road. In addition, drivers brake frequently due to traffic jams, reducing the energy efficiency of gas-powered vehicles and increasing pollution. Our city managers need to find an appropriate solution to traffic congestion to alleviate the pollution and reduce time spent on the road. Next, let's look at parking problems from 2 aspects: parking management and experience. First, in terms of management, most parking space details are not clear enough. Navigation apps prompt you about parking lots near your destination, but they can't tell you whether there are available parking spaces. When you arrive, you may find that the parking lot is full. The tidal effect in parking lots is also a problem. The parking lot is congested once in the morning and once at night. For example, when we go to work in the morning, we drive cars from parking lots near home and park them in our company's parking lots. In the morning, parking spaces near home are unused. When we go home in the evening, parking spaces in companies become unused. So there is a time-based imbalance for these parking spaces. In addition, for parking space managers, charging and inspection problems also exist. They can centrally manage parking spaces at the entrances and exits of shopping malls, but they may have trouble charging roadside parking spaces. Another problem is illegal parking. Traffic police give parking tickets to vehicles that violate parking rules, but this is a waste of manpower and resources. In terms of parking experience, drivers can't find idle parking spaces because it's difficult to obtain parking space details. It's also difficult to find cars in parking lots. For example, you park your car in the large parking lot of a shopping mall. But when you finish shopping and head back to your car, you can't find it. Congestion at the entrances and exits of parking lots during peak hours is also a problem. These are the parking problems we may encounter. Next, let's move on to street lamp issues. Currently, most street lamps in cities are controlled by time-based rules. At a certain time point, for example, around 5 o'clock or 6 o'clock p.m., when the sky is almost dark, street lamps are turned on. When the sun comes out in the morning, street lamps are turned off. However, the time when the sky turns dark varies seasonally. Lights come on too early in summer and late in the winter. In these cases, street lamps controlled by time waste electricity. There are also special cases, for example, solar eclipse. Although a solar eclipse occurs in a daytime, the sky is as dark as at night. Street lamps controlled by time can't be turned on for emergencies. Problems also occur when street lamps are faulty and need to be repaired. Maintenance is often performed in the morning when street lamps are not turned on in the morning. Maintenance personnel need to check them one by one to locate faulty ones, which is time and labor consuming. If maintenance personnel do not perform maintenance in time, faults may not be detected. If a technology can be used to monitor the running status of each street lamp in real time and report an error in time when a street lamp is faulty, maintenance will be more convenient. Energy conservation is a problem too. For example, in the second half of a night, there are fewer vehicles on the road. Leaving street lamps on is a waste of energy. A relatively intelligent system is required to automatically detect pedestrians or vehicles on the road and adjust the brightness of street lamps. The next problem is revenue of lamp pole resources. There used to be many utility poles on the road, but now they can hardly be seen. This forces us to seek more revenue from rear pole position resources. For example, we can install surveillance cameras and 5G base stations on street lamp poles. We can also install charging piles for new energy vehicles on the street lamp poles. In this way, we can maximize utilization of pole position resources. These are the street lamp problems that we may encounter. Next, let's look at the issue of firefighting management. In our cities, firefighting is still an issue that we need to pay attention to, because fires can cause great damage to our personal and public property. Small public areas in cities are the most prone to fire. Why? First, these areas are small and things are placed haphazardly. Flammable materials are likely to be dangerously placed. Second, in older places, electric cables are aged. Cable aging is a more serious threat in older restaurants because the restaurants are more related to fire. In addition, electricity piracy is severe in these places, which increases fire risks. To sum up, fire hazards are prominent. fire facilities are weak, and fire warnings are not responsive. Manhole cover management is also an obvious problem in cities. There are a large number of manhole covers which belong to different bureaus, such as water, communication, and gas bureaus. Therefore, quantity and ownership issues make managing these manhole covers difficult. Which bureau is responsible for managing these manhole covers? How can they manage a large quantity of manhole covers? Another problem is theft and loss. Manholes with missing covers pose a serious safety risk to drivers and pedestrians. In addition, the sewage pipes under manhole covers may contain toxic gas, which can float upwards from manholes with missing covers, posing additional public health and safety risks. Therefore, manhole cover management is a significant issue that requires the coordination of multiple bureaus. Similarly, there are problems with sanitation management in cities. Here, we can roughly divide the problems into 4 directions: old, low, disordered, and slow. First, the sanitation bureau does not use advanced technologies to collect information about public garbage bins on the road. Their operation equipment is old, and their management modes are outdated. Second, sanitation is mainly managed by people. Human factors seriously impede sanitation management, causing problems such as command and dispatch difficulties. Third, sanitation bureaus are often averse to using new technologies. They are still using conventional methods to manage urban sanitation. The sanitation industry lacks innovation and develops slowly. As you can see, various problems in different aspects of city management hinder the development of cities. Our city managers need to find better ways to solve these problems. We have designed a comprehensive smart city solution. We have also designed solutions for various domains, such as transportation, parking, street lamps, firefighting, manhole covers, and sanitation. First, let's look at the entire smart city solution. This solution corresponds to the architecture of the IoT. At the sensing layer, there are a large number of IoT devices, such as surveillance cameras on the road, gateways that control various sensors, and low power consumption devices, such as electricity meters and water meters. We can select the most appropriate network technologies for different IoT devices. For example, we can use the wireless 2G, 3G, 4G or NB IoT, or wide network to connect to the IoT platform. After the devices are managed on the IoT platform, data can be uploaded to the platform database and analyzed to solve problems. At the top are the solutions for different smart city applications. The advantages of such a smart city solution lie in 3 aspects: lowering the development threshold of IoT applications, reducing the development difficulties for developers, and shortening the incubation time of the entire IoT city ecosystem. In this way, a smart city ecosystem can be quickly implemented. The platform can aggregate information from all aspects of our cities and provide more convenient services for comprehensive city management. For devices and networks, we adapt devices and standards used and provide a unified management model for city managers, avoiding fragmented access of IoT applications to the platform. Now that we have an understanding of the overall solution, let's look at the detailed solutions to some of the problems described earlier. The first is intelligent transportation solution. We use application systems such as e-police and signal control to control traffic in real time. We use sensors such as cameras on the road to remotely manage city roads and relieve traffic pressure. In addition, we use electronic and automatic patrolling methods to handle vehicles violating traffic laws and regulations, thereby reducing congestion caused by the handling to traffic violations, reducing the time spent on the roads, and reducing pollution. Next, let's move on to the smart parking solution. This solution is similar to the smart city solution. In the smart parking solution, the IoT devices we need are geomagnetic vehicle detectors. A geomagnetic vehicle detector can be placed or buried under each parking space. The detector can detect the change in the geomagnetic field to determine whether a vehicle is parked. If these devices are connected to the internet, they can also tell drivers where there are idle parking spaces. In addition to detection, they can be used as collectors of parking information. The wireless technology NB-IoT is used to connect the devices to the platform because NB-IoT applies to low-power, wide coverage scenarios. The smart parking solution can not only obtain information of many parking lots, but also performs self-service charging for drivers, facilitating parking log management. Now, let's talk about a smart street lamp solution. Smart street lamps are deployed at the sensing layer. We use mesh networking to connect them to IoT gateways or carrier networks. Street lamps are deployed in large areas. The distance between street lamps is usually several meters. Therefore, wide coverage networks of carriers are used to connect them. The solution collects the information of street lamps, sends data to our platform, and interconnects the data with the public cloud to manage street lamps and centrally monitors them on the public cloud. City managers can also use mobile apps to manage these street lamps. The advantages of this is that all the scattered information of street lamps can be collected, managed, and controlled on a cloud platform, which reduces O&M costs and improves efficiency. In addition, this solution can reduce energy consumption in cities because it controls street lamps in real time based on road information to implement intelligent brightness adjustment and automatic O&M. We can see the design of street lamps later to understand their intelligence. We mentioned before that street lamp pole positions are rare in cities. Therefore, we need to make full use of these positions by implementing multiple services on street lamp poles. In addition to lighting, street lamps can also be used for other purposes. For example, we can place an environmental monitoring device on a street lamp pole to monitor the weather of an area in real time. We can also put a surveillance camera at the top of the pole, and we can put charging piles for new energy vehicles under the pole. In this way, we can make full use of pole position resources. The trend of smart city is to integrate multiple applications and devices and achieve unified management of cities. Smart city is moving towards the integration of open system, multi-applications, and multiple devices. The architecture of a conventional solution may be designed for a single industry or application. Such a solution is siloed. Now, a unified architecture is developed to manage large projects such as smart city. Each problem in the city is like a branch of the smart city solution and is managed under the unified architecture. Let's look at the smart firefighting solution. Devices at the sensing layer are intelligent smoke sensors. In addition to detecting smoke, smoke sensors can automatically report alarms when a fire occurs, eliminating the time wasted in manual alarm reporting and helping us control fires on time. We also need networks such as NB-IoT, specially designed for these devices to transmit data. So the data can be uploaded to the platform for processing. At the application layer, we use applications such as alarm handling, remote muting, device self-check, and fire prevention linkage for fire management. The smart manhole cover solution is similar. A series of sensors are installed under the manhole covers. For example, an accelerometer like the one in waistband. These sensors are triggered when the manhole cover is moved. As we mentioned before, when manhole covers are taken away, toxic gases in the sewers may float up to the street. Therefore, a gas detection sensor needs to be placed near the manhole cover. The smart manhole cover solution is similar to the smart street lamp solution. It can monitor a large number of manhole covers to implement intelligent O&M. In addition, the manhole cover status can be detected. If the manhole cover status is abnormal, an alarm is automatically reported, so the fault can be handled synchronously. The last solution is a smart sanitation solution. This solution manages the sanitation personnel, vehicles, and garbage collection in real time. It supervises the working time, routes, fuel consumption, and water spraying of sanitation vehicles, the status of garbage bins, and the checking of garbage collection in real time. In addition, real-time visualized supervision refines sanitation management, standardizes operations, and makes appraisal intelligent, making sanitation work orderly, effective, and controllable. That's all for the introduction to the smart city solution. In the next section, we will introduce the smart campus and AMI solutions. The smart campus and the smart city solutions are similar. They may use the same devices, but the scopes of campuses and cities are different. Therefore, we need to solve new problems encountered by smart campus. Although the power grid is far away from our daily life, our life is inseparable from electricity. What difficulties have we encountered in the construction of power grids? We will explore this in the next section.